In a quiet suburb, a robotic arm hums softly as it moves back and forth, layer by layer building the walls of a brand new home. There are no bricks, no carpenters, no weeks of construction noise, just precision, speed, and science. Within days, what once was an empty lot becomes a finished house, solid, sustainable, and ready to live in. Welcome to the How Factory, where we explore how 3D printed homes are built in days, changing everything we know about construction. For centuries, building a house meant the same thing: bricks, cement, scaffolding, sweat, and time. Traditional construction takes months, sometimes years, and is vulnerable to labor shortages, weather delays, and high material costs. But today, a new revolution is taking shape. One that swaps hammers and nails for robotics and software. 3D printing, once limited to small plastic prototypes, has scaled up to the world of architecture, where machines can now print entire homes from the ground up. And it all starts not with blueprints on paper, but with digital design. Every 3D printed home begins inside a computer. Architects and engineers model the entire structure in 3D software, from the foundation to the roofline, tweaking every wall, window, and corner. This digital plan becomes the house's DNA, telling the printer exactly where to place each line of material. Specialized software slices the model into hundreds or thousands of layers, each representing a few millimeters of height. These layers act like roadmaps for the printer's nozzle, guiding it as it extrudes a continuous stream of custom concrete. The result: perfect precision, no wasted motion, and virtually zero human error. Once the file is ready, the job site becomes a lab of innovation. Instead of cranes and bricklayers, a massive robotic printer is brought in, often mounted on rails or set up with a giant gantry system that can move in 3 axes: left to right, forward and back, up and down. Some printers even sit on tracks and crawl around the site autonomously. The print material isn't ordinary cement. It's a specially formulated concrete mix that's strong, fast-drying, and flowable enough to be squeezed through a nozzle like toothpaste. This mixture includes fine aggregates, water, binding agents, and sometimes recycled or biodegradable materials. The key ingredient is its chemistry. It must harden quickly to support each new layer, but not so fast that it clogs the printer. When printing begins, the robot moves with quiet precision, guided by GPS and sensors. It lays down the first layer of concrete to form the base. Within minutes, the second layer is added directly on top. Slowly, the walls begin to rise. Curved, straight, and complex shapes that would be difficult or impossible to make by hand. Unlike traditional bricklaying, where each piece must be placed and aligned manually, the printer never tires, never slows down, and never misaligns a wall. It can work 24 hours a day if needed, often printing an entire single-story home in less than 48 hours. The structure grows like a living sculpture, the pattern of each layer visible like rings in a tree trunk. A visual reminder that this home was made by a machine. As the walls take shape, teams monitor the process using cameras, sensors, and drones. They measure temperature, humidity, and curing times to make sure the concrete sets correctly. Some advanced systems use AI to adjust speed, pressure, or mix consistency in real time. If rain or wind threatens to interrupt printing, the system can pause safely and resume later without losing accuracy. The robot becomes a construction crew, architect, and quality inspector, all in one. Inside the freshly printed walls, space is left for wiring, plumbing, and insulation. Once the print is complete, human builders return to install windows, doors, and roofing. It's a perfect partnership. Machines build the bones, humans handle the details. The benefits are massive. 3D printed homes can reduce construction waste by up to 70% because there are no offcuts, broken bricks, or extra materials. They can use less water and fewer resources overall, while producing structures that are both strong and sustainable. The speed is even more astonishing. In the time it takes to pour a traditional foundation, a 3D printer can build the entire frame of a house. That means homes can be built faster, cheaper, and with fewer workers. a major breakthrough for countries facing housing shortages. In parts of the world where affordable housing is scarce, this technology could be life-changing. Entire communities of 3D printed homes are already being built in Mexico, the United States, and Africa, offering safe, durable homes for families who could never afford traditional construction. Take Icon, a Texas-based company leading the charge. Their printers, called Vulcan, can build a 2,000-square-foot home in under 3 days using a proprietary concrete called lavacrete, durable enough to withstand storms, earthquakes, and time. Meanwhile, in Europe, companies like Cobod and Wasp are building multi-story 3D printed homes, schools, and offices using locally sourced materials and even clay-based mixes. In Dubai, an entire government building has been printed, the world's largest 3D printed structure to date. The process is fast, precise, and repeatable. Once one design is perfected, it can be printed again anywhere on Earth with just a click. But what makes 3D printing so revolutionary isn't just speed, it's freedom. Traditional construction relies on straight lines and right angles because they're easy to measure and cut. 3D printing, however, allows architects to experiment with curves, organic shapes, and flowing designs that mimic nature. Walls can curve, twist, or blend seamlessly into furniture or staircases. Homes can be printed to fit local climates, reducing the need for air conditioning or heating. Even insulation can be printed directly into the walls, reducing the need for extra materials. It's a completely new way to think about architecture. Not assembling buildings, but growing them layer by layer. Of course, challenges remain. The technology is still young and printers are expensive. Each mix of 3D concrete must be tested for local conditions. Building codes, safety standards, and permits often lag behind innovation. Electrical and plumbing systems still require human installation, and large-scale printing demands stable weather and flat terrain. But with every project, these obstacles shrink. New printers are becoming faster, cheaper, and more versatile. Some can even print multi-material structures combining concrete with carbon fiber or insulation foam in the same pass. Researchers are experimenting with 3D printing in space, using lunar dust to build habitats for future astronauts. What started as an experiment is quickly becoming a cornerstone of the construction industry. The sustainability potential is staggering. Construction is responsible for nearly 40% of global CO2 emissions, but 3D printing can dramatically reduce that footprint. By using recycled aggregates, bio-based materials, or even local soil, printed buildings can be carbon neutral or close to it. Some printers use solar-powered systems and on-site mixing units, eliminating the need for diesel generators or long supply chains. 3D printing also makes housing more resilient. Walls are seamless, reducing weak points that can crack or leak. The result is a home that lasts longer, costs less, and leaves a smaller environmental mark. After printing, finishing touches come fast. Roofs are assembled and sealed, windows installed, and interiors painted. Many projects use modular roofs and prefabricated electrical systems that snap into place. Because the walls are already smooth and precise, interior finishing is easier and faster than traditional plastering or drywall. Within a week, a once-empty field transforms into a livable neighborhood, something that used to take months or even years. The first time a family walks into a 3D printed home, it doesn't just feel modern, it feels like a glimpse of the future. And perhaps that's what makes 3D printed housing so powerful. It's not just about speed or cost, it's about possibility. Imagine disaster zones where entire villages could be rebuilt within days after a hurricane. Imagine affordable housing printed directly on site in developing nations. Imagine Mars colonies built by autonomous printers using Martian soil. Every advancement brings us closer to a world where housing is abundant, sustainable, and customized for every need. As 3D printing expands, it's merging with other technologies like AI design, robotics, and smart home systems. Future houses might self-diagnose cracks, print their own repairs, or adjust their structure for temperature and light. The idea of a living building is no longer science fiction. What began as a curiosity in labs has become a global movement, one that could redefine cities, economies, and human life itself. So the next time you see a robotic arm extruding gray lines of concrete under the sun, remember that you're not just watching construction, you're watching evolution. A process that once took months now happens in days. A dream that once required thousands of workers can now be achieved by a single machine and a digital file. It's efficiency, creativity, and sustainability fused into one. From digital design to final inspection, 3D printed homes prove that the future of construction isn't just faster, it's smarter. Every wall printed is a layer of innovation. Every foundation a step toward a new world where anyone, anywhere, can have a safe, affordable home. That's how 3D printed homes are built. In days, not months. Thanks for watching The How Factory, where we uncover how the world really works. Don't forget to like, subscribe, and stay tuned for more stories of technology, design, and human ingenuity shaping the future, one layer at a time.